The successor principle is what's described in that last part of the big counting standard at kindergarten. And it's the notion that you know, for any counting number, 1, 2, 3, 4, 5, and so on, there's another number after it, and then there's another number after that one, and then there's another counting number after that one, and it keeps going. So maybe you know the name of that number, maybe you don't, but the idea of the successor principle is that you know that there must be one. For a while, we're aware of this notion of hierarchical inclusion, which is sort of the reverse of this, is that sort of for a number like 7, a set of 7 also has a set of 6 within it, and a set of 6 also has a set of 5 within it, and so forth. So the successor principle sort of goes the other direction. But as we learned about the successor principle, the connections were made in something that seems to be, you know, nearly universal experience of children starting to talk about infinity and wondering about infinity and what's the biggest number? Is it 1,000,000? Is it 1,000,000 billion? Is it a billion million thousand or something like that, right?
So if this is how many were here?
14.
Okay, so what if I told you that this group of cubes has one more than that group? Do you know how many would be here?
15.
Okay, why do you think 15?
Because there's only one more.
Okay, and how did you know 15 then?
Because 14 and 15 comes after it.
The successor principle describes that every counting number has a successor, and that every counting number is exactly one more than its predecessor. You'll see that in the standards, this is highlighted in part C, where it reads, "Understand that each successive number name refers to a quantity that is one larger."
It's occurred to us lately that it may be an indication when children start thinking about these questions, like what's the biggest number? Do numbers keep going forever? You know, and which leads pretty naturally to this notion of infinity. It seems to us that it's that point when they're really getting their mind wrapped around the successor principle, that the counting numbers just keep on going.
Yeah, one of the early instances when you see kids beginning to think about the successor principle is when you ask them to think about like the biggest number they know, and the classic one that we hear is the number 100, right? Like I know 100, or they'll tell you things like I can count to 100. Like that's the end. Like that's where our number.
I've done it.
Yeah,
I've arrived.
I've made it to 100. And then they sort of learn this new word like 101, and then it begins to sort of open their mind to the fact that, well, where does this end? Yeah. But there is a really clear time, I think, in a young child's progression of learning where they think this counting sequence does end, whether it be at 100 or some other number that they only know to. But man, once that door gets unlocked, it is really fun, and this is a really fun principle to talk with young kids about.
Infinity. Infinity is not a number, right? Infinity is an idea of forever, and so on, and so you know, as kids are thinking about this idea and asking questions about it and so on. I think it is from a mathematical perspective, as far as us presenting mathematics in a mathematically correct way, it's important that we don't frame and call infinity a number. It's rather this idea of goes on forever.